Hello and welcome to the Maths department at Dover Grammar School for Boys. My name is Ms Monday and I'm the subject lead for Maths, and I'll be giving you some information about what to expect if you choose to study A-level Maths, perhaps with further Maths at DGSB. So firstly, in this slide that I've borrowed from the Advanced Maths Support Programme, you can see how the content of the A-level is made up. The content is the same at all schools because it's the same for all exam boards. So roughly 2/3 of the course is pure mathematics, and pure mathematics will be the kinds of things that you'll recognise from GCSE as being things like algebra, graphs, trigonometry, proof, which is something that you probably will have seen at GCSE, and various other things. Statistics is all about the study of data and analysis of data, and that together with mechanics, which are equally split, they take up the other third of the course. And mechanics is very closely related to physics. It's to do with forces on objects and how objects move. So what I like to do when students come around to see us in school, as that usually happens, is give them an idea of the kinds of things that they will recognise from GCSE. I think the choice of A-level maths can be a little bit daunting, so it's good to know that there are some things that you will already be familiar with. And you can see just by looking at this screen that there are lots of things that you will have seen before, things varying from types of graphs, some algebraic manipulation, statistical graphs, vectors, trigonometry, and lots of other different things. And I'm going to talk to you a little bit about precisely how these make up certainly the first part of the course. So at the beginning of the course, we start with some things that are really just a recap of GCSE skills. These are things that you will recognise. Index laws are shown here, as is expanding brackets, factorising expressions, all sorts of different types of factorising with common factors and different types of factorising quadratics, negative and fractional indices, and various things that we can do with surds. None of that is new to anybody who studied GCSE. Then there'll be a chapter where we cover quadratics. Again, this should be things that are familiar to you, types with factorising so that you can solve quadratics, or perhaps using the quadratic formula, completing the square so that we can solve an equation, or perhaps to find out something about the curve. Various different quadratic graphs, which all have some things in common, and we can extend this into modelling with quadratic functions. Then even here we've got simultaneous equations. Here's an example of a linear simultaneous equation, quadratic simultaneous equations that you will have seen, being able to plot those on graphs, either straight line graphs like this one, or quadratic graphs to solve simultaneous equations, solving inequalities such as this one, solving quadratic inequalities as is here, plotting inequalities on graphs to find regions, either quadratic or linear. But now what I want to show you is this page, which I know you can't really read the details, but this is the contents page for the Year 12 Pure Maths book, which I've already said covers 2/3 of the content for Year 12. And you can see each of these chapters that I have circled, each one of those will have primarily work that you have already seen at GCSE, and hopefully that will give you some encouragement to know that there will be quite a lot of things that you will have already seen before. That doesn't mean necessarily that Year 12 is going to be totally straightforward. Even within these chapters there will be some quite challenging questions, even though the content might be familiar. And also, as you can see, there is still some new content to learn. In fact, these 3 first chapters, we would anticipate that you would work on those over the summer holidays. We'll be giving you some work to do and then giving you a little assessment when you get back. Based on the results of that assessment, we'll decide to what extent we might need to go over a little bit of it in class, but generally we find that most people have quite strong skills in that work, and then that means, of course, we can get into the more challenging stuff a bit more quickly, and also it helps us to get through the whole of the Year 12 course more quickly. So the book that I just showed you the contents page for is this Year 1 AS. That's the one that covers about 2/3 of the Year 12 course, and the brown book here next to it would cover the Statistics and Mechanics course, part of the course. Then, of course, you go on to in Year 13 using these ones that are called the Year 2 books, similarly 2/3 and 1/3. However, what we tend to do is we try to get through the Year 12 work, as I've just said, a bit more quickly, so that we can actually start this work before the end of Year 12, and that puts us in a good position to finish the content early enough so that we can do some revision before the exams. So I've mostly talked about the pure math side of things, but here you can see there's some statistics graphs that you might recognise, histograms at the top and cumulative frequency graph at the bottom, just to show that those kind of skills are still expected knowledge. And here there's a few Venn diagrams, those Venn diagrams showing different sets within the universal set. And that, together with the tree diagram, would lead to you being able to answer questions about probability. So we'd start by talking about frequency distributions and then go on to talk more about probability distributions by the time we get into Year 13. Then in mechanics, you could be doing anything from looking at speed time graphs or distance time graphs and analysing those. You could be looking at the forces on a particle or on an object. Or you could be doing something like looking at the path of a projectile, the path of something that has been projected into the air. So that's just about it for the A-level maths. At least hopefully that's given you a general idea. For those of you who are interested in further maths, the pure maths, it again makes up the bulk of this content, at least 50% of the A-level. We don't offer AS level generally, but even so, 50% of the course would be pure maths. The remainder, even though it mentions an option here, really the options are decided for you. What we offer is additional mechanics topics in the form of further mechanics 1, and then the other module is the discrete or decision maths. So just to give you a little bit of an idea, we start talking about extended springs or Hooke's law, which you may be familiar from physics, and collisions between objects. So decision maths will be something that you are not so familiar with, but so you can see some examples here. So I've put the tube map there because it's a very good example of a network, and networks are a very big part of decision maths at A-level. You might be finding the shortest path on a network. You could be using a type of network to look at critical path analysis, which is very useful for designing big projects and deciding which order you have to do certain tasks in. And then at the bottom right here, you can see something that might be a bit more familiar to you, because we've already talked about inequalities being shown on a graph. And this is an example of that, but it's also an application, it's a way of applying that to a topic called linear programming, so that you can optimize your resources. So you might also then be interested in thinking about the career opportunities that will become open to you as a result of studying A-level maths. And on this slide, you can see quite a lot of different ideas that are being put forward by, again, the Advanced Maths Support Programme. I do realise that when you're studying GCSE maths, it might seem difficult to have any understanding of how some of those quite abstract concepts, some of that algebra skills that we use, how could that possibly be applicable to a real life situation? Well, there are very many ways in which it is, and here's some ideas that might be of interest to you. And this is a slide that often is of interest to students, because this is a message that we quite often hear, which is that those who have studied maths beyond GCSE tend to fall into a category where they earn, in this case it's talking about up to 11% more as a result of having studied A-level maths. Now, of course, that probably means that the kinds of jobs and careers that those people end up doing just tend to be the kinds of things that are more in demand. Well, as I've already suggested, there are many subjects that maths is perfectly well aligned with. What tends to be the stereotypical things that maths is linked with: finance, science, technology, engineering, that kind of thing. But also definitely the social sciences, anything that requires data analysis, and also increasingly in the creative subjects as well, there can be applications for maths. And here's just a few more slides just indicating the kinds of things that maths can be applied to. Here you can see technology again, engineering and science, and even human behaviours and interactions. So now when students ask me what's maths useful for and why are we doing this, how can this possibly be useful for my future life, I basically say to them, well, it really does depend on what you intend to do, and it's really only limited by your own imagination, because there are so many different applications for mathematics. On this slide you can see a link to an article talking about top university places, the Russell Group universities, and the fact that maths is something that other degree subjects are very keen to. I'd like to leave you with this quote. So although I've talked about all the different applications of maths, and those might be some of the things that motivate you to want to study maths, I also want to make it clear that the study of maths in its own right, for no other reason than the fact that it exists, I suppose, is certainly something to be aimed for. So you can stop and have a little look at that quote while I stop talking. I'm just going to say thank you for watching and for considering studying A-level maths at DGSB.